In this recording, we're going to learn how to simplify rational expressions. Basically, rational expressions are fractions that have variables in the denominators. And the way to simplify them is to factor and divide out any common factors. So you really got to be good at factoring here. Okay, I'll give you an opportunity to write down the example and then play the recording when you're ready. Okay, in this example, we've got is a fraction that has variables in the numerator and denominator. Okay, what we want to do is factor both the numerator and denominator, and then divide out any common factors that there are. Okay, so I'd like you to factor the numerator, factor the denominator, then play the recording when you've done that. Okay, so hopefully the numerator you took out a greatest common factor of 2. So you have a 2 times x plus 5 in our numerator. In the denominator, don't have any greatest common factor, so I'm going to look for numbers that multiply to be 30 and add up to 11. And hopefully you came up with x plus 5 and x plus 6. Okay. Because we have this common factor of x plus 5, we can divide it out. Because x plus 5 over x plus 5 makes a 1. Okay? So what's left is 2 over x plus 6. Now, I'm not going to use the word cancel here because that gets confusing to students. When can I cancel? Oh, can I cancel out this x and this x? Because cancel is just not a mathematical operation, but divide is. So when I have the same factor in the numerator and denominator, they divide out to make a 1. I cannot divide out this 2 and this 6 because they are not both factors. The 6 is not a factor of the entire denominator. It's just a term. Okay, again, a factor is something that's being multiplied, has parentheses around it, or it's just a number next to a variable. Those imply multiplication. Or it's an exponent, which applies multiplication. A term is an expression being added or subtracted. So this x plus this 6, they can't be separated by division, so I cannot divide out the 2 and the 6. That's finished. Okay. In our other example, I want you to recognize factors that are negatives of each other. Okay, so right here, we've got a 4m minus m squared. Okay, I'd like you to factor out the numerator and factor out the denominator, then play the recording when you've got it. Okay, so hopefully you recognize in the numerator, I've got a m as the GCF. So I've got a 4 minus m left. In the denominator, I've got a 2 as the GCF, and I've got an m minus 4. Okay. Clean that up. These are not the same factors because the order matters in subtraction. So what I like to do before we can factor this further is to have you consider this little situation. I want you to pick your favorite number. Okay? Mine happens to be 15. Then I want you to have you pick your second favorite number. Mine happens to be 45. Okay? So subtract your favorite number minus your second favorite number. Okay? Then I want you to flip that over. In the denominator, I want you to change the order of the subtraction. Okay, so whatever your favorite number is minus your second favorite number, and don't tell me you don't have a second favorite number, you definitely do. Then take your second favorite number minus your first favorite number, do the subtraction. So in the top I've got a negative 30, bottom I've got 30, I simplify it, it comes out negative 1. And I guarantee if you did this correctly, your pairs of numbers simplify to be a negative 1. It always works. Okay. Now, in a situation where I have opposite binomials, okay, so I have that here, 4 minus m, m minus 4, they divide out to leave a negative 1 as the quotient. Okay, they're not the same. They don't divide out to be a 1 like we had up here. I guess I can write my 1s up here. They in fact divide out to be a negative 1 over 1. You might say, well, where do I put the negative 1? You can put it on the top or the bottom, but not both, because then I have negative 1 over negative 1, which would be positive 1, right? I can prove this to you a little more rigorously. This was just an example. It wasn't a proof. I guess we can show it with variables. We'll go a minus b over b minus a. And in the denominator, I'm going to divide out or factor out a negative 1 from the bottom. Okay? So if I factor out a negative 1 from b, I get negative b. Okay? Because negative 1 times negative b is positive b. And if I factor out a negative 1 from a, I get positive a. Okay? And in fact, the order with addition doesn't matter. So in the denominator, couldn't I change the order of these terms, so I can write it a plus negative b. And of course, that is the same exact thing as a minus b, right? These are the exact same thing. So they divide out, and all I'm left with is a 1 over a negative 1, which is what we said. And that all equals negative 1. Okay? So now that we know that that's negative 1, we just end up with a negative 1 times m, which is negative m, all over 2. Okay, so that's the important thing here, to recognize factors that are negatives of each other. Negative 1 is the result when you have 4 minus m over m minus 4. Okay? So what is allowed when you're simplifying a rational expression? There's a lot of confusion from students on this. Basically, we're only allowed to divide out common factors. And how do we get factors? What's the verb that gets us factors? Well, we get factors by factoring, right? I have a colleague, Mrs. Techman, who says, if in doubt, factor it out. All right, it's a great motto for this unit on rational expressions. If in doubt, get factors. Factor it out. Then you'll be able to work from there. So what do factors look like? Well, factors are any types of expressions that are being multiplied. So just jot down a few examples here. Some examples of factors might consist of something like 3 times x plus 2. Okay, the 3 is a factor, and the x plus 2, because it's got parentheses around it, is a factor. 7x squared. These are all factors. The 7 times an x times an x. Exponents are factors. So any number next to a variable implies factors. Okay, so you can see factors by numbers next to variables. You can see it by exponents, and you can see it by parentheses. Over here, so these are factors, right? Terms are expressions that are being added. So these are terms. X plus 7, okay? 2x, 2 times x, we've got factors here, but 2x minus 4. Okay, those are terms. They're being added and subtracted. You can't separate them by division. Okay, so terms are expressions being added or subtracted. All right? And lastly, we might be interested in knowing values of a particular rational expression that would make the expression undefined. What you need to think about here is, what can't we divide by? If we divide by what number does it make an expression undefined? Of course, that's divide by 0, right? You knew that from a few years back. So if we divide by 0, that makes the entire expression undefined. So really the key here is just to look at the denominator. What would make the variables, what values of the variables would make the expression undefined? Well, it's when the denominator equals 0. I'm just going to abbreviate here. When the denominator equals 0, that's a problem, because we'd be dividing by 0. The numerator, folks, can be anything at all. It can be positive or negative. It can be 0. Doesn't matter. So basically what I'm going to do is I'm going to say x plus 5, what would make that equal to 0? Oh, that would be negative 5. And here, x plus 6 equal to 0. Okay, well that would be x equals negative 6. So the values of the variable that would make the expression undefined would be negative 5 and negative 6. Okay, and down here we're just interested in this denominator. We factor it. 2 can never equal 0, so I'm not concerned with that. This one, however, m minus 4 equals 0. Well, that would be positive 4. Okay, you might be asking, well, could I just do that in my head? Can I just look at this and say negative 5? Yes, you certainly can. I hope you will. Thanks for watching.